All right. Hello, hello everyone. Welcome to this Dixie. Welcome to this Q&A, everyone. So, I do have a call in. Say hello.
Hello.
So,
Oh,
so just one moment. I have so, let's get this started. So let's start with the Morse with you guys with your call-in. So you said I'm gonna have to go back into your text here. So one of you said what makes a tornado. Just
that was me. I said who makes a tornado. What makes a tornado?
All right.
That was me.
All right. So might sound like I'm reading off a script, but I'm gonna try and go off what I'm gonna say as best as I can. So basically, inside thunderclouds, humid air rises while cold air falls, which makes sense because cold air rises and all that with physics, along with rain or hail. These conditions could cause spinning air currents inside the cloud and a rotating updraft of air, often driven by wind shear, which I can explain more later because I'm sure there might be some questions asked about just specific properties of predicting weather. And then that intensifies and extends downward to the ground, which could form a tornado. So that should answer your question there.
Temperature changes, right? Maybe?
Yes, temperature changes. Correct. So.
Does that make sense?
Does that make sense? Does that make sense?
Yeah.
All right. So and then one of your questions, I find funny questions was that you said, is it ever going to stop raining? Obviously, I don't know. I don't know that. I can't predict when it'll stop raining, but obviously it did stop raining. There's obviously rain in the forecast. But so and
But why is it raining so much lately?
Because all these storm systems are coming into the United States, and we're just getting a lot of that leftover rain from all these storm systems. Correct.
West and
Correct.
all that?
Correct. Correct.
Where are they blowing in from?
They are
Coming over the Rockies?
Some are coming over the Rockies, and some are also. There's basically our weather pattern right now is. Oh, actually, I can for everyone on the video. I can actually go up to here. Obviously, you can't see this, but basically, this is our weather pattern where we are having a ridge here in the ridge here in the west and the trough in the east. So basically that's bringing warm air to the west and cooler air to the eastern part of the United States. So our normal weather pattern that we need to have for significant severe weather is this weather pattern, where we have troughing in the west and ridging in the east. So that's how you get those big storm systems coming into the central plains and southern plains and back over to the Midwest. So yeah, that's I just wanted to explain that for everyone on that video there that you're watching, which obviously you all can go watch. Possibly. So we're going to get to the other questions from our. You can stay if you want. Here, just one moment.
We're going to stay for a while. I want to hear the other questions.
All right. So, one of our other questions was, what happens when from another family was, another question was, what happens when a hurricane meets a tornado? So, basically, the hurricane and tornado can modify each other in different ways, like the hurricane can intensify from the energy from the tornado, and the tornado can intensify from the energy from the hurricane.
Okay, so
And
they
then,
feed each other.
correct. And then, I find this was very interesting, and I actually looked this up a while back, but the next question is, what is the biggest hail record, and did it kill anyone? So, the biggest hail ever recorded was 2.25 pounds, 1.0 kilograms.
How big was that?
Yeah, what could you compare it to?
We don't probably like a rock. I don't really know. I don't really know the size of. It didn't say the size. It just said the weight when I got that information. So, and it unfortunately killed 92 people with that storm.
What
were they?
What
Yep.
hailstone?
No.
The 2.25 pound hailstone.
But wait a second, was there a reason they were outside? I mean, was it a public outside event or something? I mean, do you know that? Or
No, I don't know that. Obviously, I should know that because
No,
it's
it's
a TMA,
okay.
but I don't know that information, unfortunately. But all I know is what I looked up and the information I was
Yeah,
asked
great.
there.
That's a lot of fatalities.
So when the hurricane meets the tornado,
Yes.
it feeds off each other. Does it just intensify the tornado? 'Cause they're both
Correct.
rotating so
Correct. That is correct.
Does it also intensify the hurricane or just mainly the
It can.
tornado?
They could kind of even out, or it could be either one.
Can they combine into one massive super tornado?
No,
Just
I don't.
curious. I guess that's where maybe
I-
Like
yeah.
would be
And
like a weather
Yeah.
thriller movie. It'd be like the hurricane tornado.
All right.
Tornado.
All right. Our next question was, how many lightning strikes does the Earth get in a day?
Oh my.
And the Earth gets 8 million
What?
lightning strikes a day.
That's crazy. But I guess it figures if
that
you're
makes
talking
sense.
Earth.
Joshua, do you
Does
know
this-
what place gets the most
No,
lightning
sure.
strikes on average?
It's actually
Wait,
Oh, we
I
need a
have a
regular
question
one.
as well.
What's wrong with this one?
By lightning strikes, does this mean like lightning that touches the ground or makes contact
Correct.
with an object?
correct. More than likely, I think that's the
Crazy,
case.
Joshua.
So not cloud lightning.
Yeah, because I was thinking of cloud lightning and lightning in the sky in general. But wow.
So like cloud to cloud or just striking the earth?
Around the Catatumbo River in Maracaibo, Venezuela.
Very good
Really?
pronunciation there, Josh.
So maybe like a rainforest area?
Right.
Mm-hmm.
Where'd you say it was, Joshua?
Maracaibo, Venezuela, on the
Oh, okay.
Catatumbo River.
That's great
Oh.
pronunciation there,
Well, we
bud.
just studied about the Catatumbo River, didn't we? In
Oh,
Venezuela. We
okay.
just, yeah, we just learned about it. Not much, but we just read about it.
Let's get going. Okay, our next question.
Sorry, it's wet. Slimy dust.
Let's move over to this here. What our next question is can you explain the different types of clouds and how each are associated with specific weather?
Oh, that's a good question.
So basically, for this question, obviously it's gonna sound scripted, but this is the best I can do with me not knowing the information.
That's
And
good
just
that
now
you gotta
looking it up.
You gotta get it from somewhere.
Right.
Smart people say, I don't know, but I'll find out.
So fluffy clouds are often associated with fair weather, while dark gray nimbostratus clouds can bring rain or snow. Stratus clouds suggest overcast or foggy conditions, and cirrus clouds, while often fair, can also signal an approaching weather change. Wall clouds often mean that there is more of a chance for a tornado to form. Anvil clouds is in its mature stage, or the thunderstorm is likely strong and potentially severe. Shelf cloud, and that anvil is basically shaped like an anvil, like you've seen an anvil, right? Where it's shaped like this, where it's kind of like, yeah. Shelf clouds indicate an approaching squall line or a line of strong thunderstorms, often accompanied by strong winds, heavy rain, and sometimes hail. All right, so that question,
And that's shelf cloud.
that is a shelf cloud, correct?
Hey, Mom, you're not going to tip over to the side, are you?
I was a little concerned about that.
All right, so now let's get to another family's questions,
Are
which
those all more questions?
so sorry everyone on the video. I was just trying to explain names and I can't hit and I can't
Just a picture.
was just doing a picture. All right. So basically the last section is from another family. So the first question was so the first question why aren't there tornadoes in Alaska?
Oh, aren't there tornadoes in Alaska?
That's a great.
And it says Alaska is a mountainous state with a cold climate, making it less conducive to the development of tornadoes. The specific weather conditions needed for tornadoes, like warm, moist air colliding with cold, dry air, are less frequent in Alaska compared to areas like the Great Plains in the U.S.
Okay,
Additionally,
So they don't have, yeah.
Additionally, the sparse population in Alaska means that sometimes tornadoes might go unreported.
Okay, sure.
So,
that's a really good question or a good.
So, and then the second question was, how will the Sahara dust storms affect weather in the U.S.? Hey,
Yeah, 'cause that'll
well,
block up the sun.
hazy skies, reduced visibility, and potential impacts on air quality, colorful sunrises to Florida, and cut down on thunderstorm activity. So those are different effects that they'll have on our weather here in the United States.
So yeah, that dust will make it all the way over here from Africa.
I
Well,
Yes.
so you said something.
yeah,
Okay. Well, it
like how it can carry over to
Yeah, I
with
guess
all
that
the
makes
air.
sense.
Yeah,
Yeah, if you get enough dust.
yeah,
It's amazing.
yep.
did you look up the answers and write them down ahead of time after you got the questions?
Yep.
Well, good for you, Joshua.
That
I wrote-
could hurt so much.
I wrote the last section down while we were going to the lakes, kind of secretly.
Oh yeah, I saw you working on that.
yeah,
Writing down.
I didn't see that.
I didn't see it either.
Well, I was the one sitting next to her. So.
yours.
I didn't notice.
All right, so now I think that's all the questions that we have right now from the people that are not here. So now let's get to the people who are here.
I have a question, Joshua.
Yes.
So I heard that there's some wildfires going on in Canada right now. Are the wildfires up there gonna affect our weather here? Or I guess like, do you know like kind of generally like how
Yeah.
wildfires can affect weather patterns?
We learned about that.
I'm
What do volcanoes?
It was-
What do volcanoes exploding do to the weather? Which isn't the same as a wildfire, but
It
same
pr-
concept.
it produces ash clouds
Which does
and
what?
which carries and blocks the sunlight from coming in.
So wildflowers, fires
Fires.
do the same thing to on a
Yes.
shorter extent,
Yes.
right?
Yes.
That makes sense.
So it's gonna create kind of air pollution and stuff. and
Correct. Which
Less sunlight.
unfortunately
Less sunlight
happens.
affecting temperatures.
Would the heat from the wildfires kind of affect weather patterns? Because I know heating and cooling causes a lot of, like heating and cooling the air causes a lot of weather.
Potentially. It just kind of depends.
Yeah.
So probably our air quality isn't going to be too great
Right.
coming up.
I
Right.
would think one
Maybe.
thing with the heat on the fire would be it would be heat, but it would be dry air.
Yeah.
Right.
Oh, that's true. It would dry.
So it would maybe this is just from what I'm learning from these guys that even just this because it's warm maybe doesn't make storms. It has to have be warm
moisture.
and humid.
Mm-hmm.
So
Yeah,
that
so it's not
fire would dry
necessarily
the air out. I would think.
It's not necessarily going to create some crazy.
I'm not a weather person, but
So, I have a question, Joshua.
I can do it.
You always hear about dew point. Could you describe what dew point is and why, like all the weather people on TV always say the dew point is. So what is it and what significance does it have?
Let's. We can actually. I'll find more information here because I've never been asked to break that down, so I will.
That's great.
I'll do that right now because I'll be making just specific videos, like one on dew point and
Oh,
other
that's cool.
things.
You're taking Aunt Sherry's suggestion.
Yep.
You're gonna explain.
Yep.
Yay!
Yep.
That's
That would
exciting.
be
That's a
great
cool way to
idea.
expand your weather channel into
Yeah.
more
Subject.
weather, but also teaching people more.
Knowledgeable. So that we can understand them and it would be kind of a teaching thing for his audience as well.
Yes.
So yeah, and then
Yep.
we can all understand the technical stuff you talk
Yeah.
about in your videos.
Right.
Yep.
What were you gonna ask, Joshua?
So
Joshua. This is Mrs. Moore and Brendan. We're going to hop off because we've got another thing to get to, but can we catch the rest of the questions on your recording later? Okay.
Hey, guys.
Thank you for joining.
Happy birthday,
So-
Brendan.
Happy birthday.
Thank you.
All right.
Bye.
Bye bye.
Bye.
All right. So all right.
What's next?
So Aunt Cherry, you asked about dew point. That's that's what I was going to. Sorry, just wanted to. So, not that question. All right. What is?
Isn't it a point where
It is. It says it is.
Phone a friend, there's unavailable.
That can't wait to step in and
Dad's chomping at the bit?
I'm just kidding.
No, letting him do his thing.
You know how it is when you're.
Bite my
I have
tongue.
the answer. I have the answer.
The air gets saturated or something?
I need to know. Hey, I need to know this for my
You do.
making those videos. So that's why I'm looking it up on my own, so I know when I make
Smart.
the videos.
That's how you'll remember it best also. Just
Yep.
looking it up and finding. That's why we had you do that in school.
Yep. So it says the dew point is the temperature at which the air becomes saturated with moisture.
So it's basically how much moisture the
You
air
can
can hold.
you can step in that.
Essentially, it's the point is where basically moisture would begin. It's the temperature, the dew point. So you have humidity, and you have dew point. They're actually directly related. So dew point is the temperature at which the moisture in the air will condense.
Okay.
So it's related to the amount of moisture or humidity. So when we talk about humidity, that's the dew point with the ratio over what the actual air temperature is. So
Okay.
as those two get together, the higher the humidity. So when you hear, oh, it's 60% humidity or 65% humidity or 20% humidity, that's the ratio between the air temperature and the dew point.
Okay, that makes
And
sense.
you figure out the dew point by basically doing what's called a wet bulb. Back 60, 70 years ago, it was called the wet bulb before they called it the dew point. And literally you have two thermometers. One is essentially wet. you actually have a wick. Think of it like cutting your shoelace off. This is how I made when I was 12 years old. Made a dew point, an instrument to measure the dew point. Two identical thermometers. One has water that's being whipped up over the bulb, and you'll see that one is lower than the other. And so if you have less humidity, they're going to be further apart because it needs that temperature to fall down to condense the moisture that's in the air.
Okay, that makes sense.
So that's why you'll hear them two measurements, but they are actually directly related. You'll understand the math behind them.
Yeah.
Yep.
So that's why when it's 98% humidity, it feels like you walked into a wall of moisture outside.
Yeah. So if it's like
'Cause it's
80,
real-
if it's 80, go ahead. Anna.
The air is really soaked with is dense.
moisture.
It's like a sponge that needs to
Soaking
be
up,
squeezed
yeah.
out.
Exactly. So you might walk
Okay.
outside and it's 90 degrees, but you see that the dew point is like 70 or something. Now you know that
Here,
that's.
sorry to interrupt
so-
you, but I can actually look up the current dew point.
Up on the roof.
Yep.
I would think it's
So,
kind of low.
Right now,
as an
it's way
example, when
lower
we're chasing
now, it's
tornadoes, that's one of the huge factors that we look at is what are the dew points going to be at the time of what we call initiation. So at 3 o'clock to 7 o'clock, the magic hours, we look to see, are we going to have 2 or 3 degrees separation? We're looking for at least 5 or less degrees of separation in humidity. That tells us we have enough moisture in the air and we have dry air behind. That closer that dew point is. So as an example, when we were chasing some of the other storms, it was 70 degrees out, but 68-degree dew point. Really high humidity. That's exactly what we need for tornado
But like you said,
initiation.
the temperature was lower closer to the dew point.
Mhm. And so just take and divide 68 by 70, that's going to tell you what the percentage is.
Okay, that's
Mhm.
interesting.
And that gives you the humidity. Humidity is measured in percent.
So you really do factor that, looking at that number,
Absolutely.
whether could be a tornado or not.
Exactly. So
More
think of the
potentially.
tornado as a recipe for a cake. So I have to have this ingredient, I have to have this ingredient, this ingredient. I can have all those ingredients sitting on the table, but I don't have a cake.
Yeah.
Yeah,
Okay?
you have to combine
But
them.
I have to combine them. Do I have all of them combined? And also the quality of each of those ingredients are also pertinent as well. And even still, you can have all those ingredients together, but unless you're mixing it, it doesn't come together.
Right, that's
So-
interesting. Okay.
And so we look at lots of different factors, some less technical, some more technical, that help us identify, am I going to go down to Springfield? Am I going to go to Cape Girardeau?
'Cause of
Am
the-
I going to go to Columbia? Yeah. Where am I going to be? Where is the highest probability at what time? And where is that going to move? And where is that massive air temperature humidity? When is that going to move into a point where it's going to initiate and we can be right there to watch it happen?
Yeah, okay, that's interesting.
Joshua, you were going to say something.
So the current temperature right now is 71 degrees. The dew point is 59.8.
Good save.
And the humidity is 68%.
Oh. Man, it didn't feel that humid earlier, but I guess maybe they got more.
So what happens also when the temperature drops? So the volume, the moisture that's in the air didn't change, but yet the temperature dropped. So what's that going to change? Is your-
shorten
Your moisture is going to become more or less dense?
more.
More, yeah.
More dense.
Yeah.
So your humidity is going to go up or down.
Up.
Good job.
Better math.
I have a question, Joshua. Whenever, or was it somebody else's turn?
Oh, I think you can.
I think you can jump in.
Okay, so these meteorologists always look at the little screen and they'll go, "Oh yeah, do you see the rotation?" You can never see the rotation. I don't ever understand. Do you see the hook? I'm like, no, I
They
never
see
see
it.
the hook.
They see
How do
it.
they see it? They're pointing. They're like, "Oh, look at that."
It's
It never
because
makes
the
any sense
So
to me.
Joshua,
So-
bring up a picture. Bring up the El Reno or Joplin tornado.
Because I
Radar
mean,
image.
I get what you're saying. You're not literally going to see
My
it spinning,
hands are
but it
always
doesn't.
Particularly the vorticity. So look up the El Reno F5 tornado vorticity, which will show up. So you can show Ann and everybody else. So look at, there's one aspect. So double click and make that full screen, and then step back from the screen so everybody can see. Okay, so step back. That's just so
Oh.
tell people what that's a picture of. First
So
off.
this is a picture of the
Oh, can you?
El Reno F5 tornado in El Reno, Oklahoma.
Well, what is the picture from? What type of an instrument?
It's from the radar,
Okay, and what type of product from the radar?
the composite reflectivity.
Okay, so this is telling us what? What is that? What is that telling you? What does composite reflectivity tell us from the radar?
How intense the rain is, and base
Rain or
No,
just the what in the air?
the
Amount of
amount of moisture.
moisture in the air. So what color? What do the colors tell us?
So the green tells us like light rain, and all the way to dark red tells us heavy rain, potentially, possibly a hail core.
So
Where's
so
rotation then?
This
That
So,
would look right
this
there.
is not going to show us rotation, and that's why I wanted him to bring up a picture that shows here's the radar image and here's the vorticity image. So, but where on there is that tornado going to be?
the tornado is going to be. So this right here is the hook.
Yeah, okay, that makes sense.
This
I can
is
see
a-
that on
and-
that one.
This is an F5. This is like big, huge, 2.5, 3 mile wide tornado. So it's very emphasized. It's highly emphasized in this type of a view. So if you learn kind of the worst, then you get down to some of the more
You can see.
obscure,
Okay.
different weather conditions. They end up being a lot more. See if you can pull up the vorticity of the Reno F5. I want to look at the vorticity product.
When did that happen?
2011 or yeah.
It said 2013 on
Okay.
that picture.
So there's been 2 EF5s that have gone through El Reno. They were pretty devastating.
The 2013 one, was that the one that killed the one storm chaser? The El Reno tornado
Yes.
in Maris?
And his
Yes.
son.
Mm-hmm. Mm-hmm. So just search
Alright.
on basically El Reno F5 vorticity image. There, click on that. Open that, and this will demonstrate so that they can see. So why don't you take a step back and kind of step over here and explain
You move
what
your
you're saying.
chair so Grandma can
I'm sorry.
for
I
signature.
can see through the hole.
She was
I can see.
She was being creative there.
The chair over where Dad is.
So
And then Dad
First-
can move around.
first off, where does that picture on the left come from?
This picture comes from the same tornado from that on that.
What instrument?
Last
What
picture.
instrument provides that data?
This data is from the radar, and this
Both of-
is the
Is just one of those, or both of those from the radar?
both of them are from the radar.
And those are just 2 products of a couple dozen products that come from the radar.
Okay.
And so what are we looking at on the right, Joshua?
The right is the general composite reflectivity, like we were looking at on the
Okay.
last
Okay.
picture.
Okay. And so what is it that we're looking at on the left?
That is
That product.
that is the velocity, basically.
And what does that tell us?
That tells-
what feedback
measures
does
wind
that give us
speed.
with
Oh,
Doppler radar?
okay.
Wind speed and
Wind direction.
Okay.
Okay.
And it tells us what is the orientation, if you will, of the direction. Or so it tells us direction, but it only tells us 2 directions, right?
Yes, away and coming to the radar.
Okay.
In the direction.
So yeah, keep on going. So if you look where they've got a circle around there, and you may have to step up and take a closer look at it. So tell us about that area on the screen. What does that mean?
This is a couplet, basically, like
That's what you refer to it.
yes.
But what for somebody who doesn't quite understand that, what is the radar telling us, in other words, about the wind at that particular area? What direction is that wind going?
So the red is wind going away from the radar. So the red is wind going away from the kind of away from the radar,
Okay.
and green is going toward, which actually makes sense because red is more like,
I always
More of a
think
darker-
green is go, so it's coming
yes,
towards.
yes, basically, and red
Okay.
is
And so, what happens? What do we see together, right, almost next to each other, right there?
Red and green.
right, red and green.
Green.
So that means it's
So if I've
spinning.
got air within close proximity doing this, or in other words, doing this, I can only see away, so that implies there's
That-
also this going on as well.
Mhm.
And Joshua, we're looking at this from what kind of an angle? If we were to think of this as a three-dimensional model, what angle are we looking at that as? From what angle?
Up.
Or
Up,
from
Down.
Yeah,
top
we're looking
down.
Top
Okay.
So what else? What other things can we do with the radar to look at different aspects of the radar? We can do what?
Move up in tilts.
Okay, and that does what?
That helps signify how deep the rotation is.
By looking
But-
where. So if I'm tilting, what is it? What perspective? What additional perspectives is it showing us?
It's showing us more angles, more
So
angle perspectives.
at the same level or
at different levels.
Oh yeah, that makes
So
sense.
it means so you can look. So what happens when you get about 30 miles away from the radar? Because the radar only goes straight. It's radio frequencies. Think of it like a light flashlight, right?
Mhm.
So the further you get away, but then we also can look up further in the atmosphere. How high are most tornadoes? Not tornadoes, but thunderstorms. How many thousand feet? Do you remember?
40,000 feet.
They can, but certainly the 60,000
50.
feet. So if you think about 5,280 feet in a mile,
Mhm.
you're thinking your thunderstorm is 50 to 60,000 feet. So we can look and see
They're
that column of
miles
air.
up.
Oh yeah, 55,000 feet is a
You're
typical.
telling me that a thunderstorm that might be in my backyard might be that high up?
Mhm.
That's crazy.
Because if you look, how many times has it been blue sky, but you look to the north or the south or the east and you see this big, huge cloud.
And
And
it
that's,
seems
that's
like it's
hundreds
right
of
on.
miles away.
I was gonna say it seems like it's right next to you, but,
But
it's
if you go
hundreds
and
of
look up
miles
on the
away.
radar, you'll see, oh, that's down southern Missouri. They're a typical thunder cell mesoconvective complex, as we call them, is 50 to 60,000 feet.
That's crazy.
It
And
is
when you
crazy.
get the EF5s, that's when you're seeing. So the scale is what, Joshua, for the Fujita scale?
EF0 to EF5.
Okay. And so usually because of the velocity and the intensity, that's where you're getting those 55 to 60,000 foot tops. Because there's another product that we look at, Joshua. What do you and I also look at too when we're watching storms? Echo.
Echo tops.
And what does that show us from a radar product?
How far the
How
how tall the storm is.
So is an EF5 storm going to be taller than an EF3?
Yes.
And
yes.
so it would have more velocity. And
It's gonna have
do more destruction.
tighter rotation.
Okay,
Yeah.
that makes sense then.
And
so-
so that's where we can look at the intensity of a cell to see if it has potential to be tornadic based on these number of products. to
And
look at.
and the green and red next to each other basically indicate that it's spinning.
Exactly,
Correct.
because you have
Correct.
wind in very close proximity to each other that's going in different directions.
Okay.
You know, and versus if you see a thunderstorm come through, you can see a gust front. It's all going in one direction, and that's one of the specific locations because you can have what's the picture on the right, which is the composite reflectivity a lot of times, and not have any vorticity convergence. But
Okay.
so it's like there's multiple pieces in the puzzle that you put together, kind of like the recipe in the cake. That's where the weather, and they don't explain that. That's very unfortunate, because just very elementary ideas of explanation like that, people go, I think I understand.
Well,
it
they're
now."
just always on the
So-
TV. They'll point and they'll be like, "You can see." I'm like, well, I can't see
Wait,
that.
so
No.
Joshua.
Yep.
So tornadoes that have a tighter rotation are more intense?
Correct.
Interesting. I mean, I guess
So
that makes sense.
the
There's
ones
more.
that are really big and wide are less intense than the little
No, they're going to
No,
be more
it's gonna be
intense.
the
So
opposite.
it's going to spread
It's gonna be
out.
the opposite. The those bigger ones are gonna
Or
be
picking
more
up
intense.
more outside
Yes.
debris, which is
And
causing
then what's
it
the
to
other
look
product
bigger.
that we look at too when we have an active tornado? What's
Correlation coefficient that tells us the kind of amount of
Debris. is
debris.
getting-
Yes.
we can actually see in the radar when you got shingles and
Yeah.
trees.
That's color
You can
blue,
see.
right?
Huh?
That's blue, right?
Yes.
If you can see.
It's actually kind of multi-type
Yeah,
colored.
good.
What the product is actually telling us that I see all rain, but now I'm seeing something of different density. So if I have rain and hail, that kind of ends up showing a bit the same. But if I have car parts, if I have trees, tree limbs, if I have shingles, those are much different density than what rain or hail is going to be.
Yeah.
And so we see associated with those two indications, we can look at a third product and see, oh, here's an anomaly. And we can make a pretty good supposition. So when they say radar indicated tornado, the National Weather Service, that's exactly what they're doing. They're making those looking
Based on what they see on the radar.
Exactly.
Not necessarily that someone
Spotted.
literally
Correct.
saw
So
it.
tell
Not on the
tell them,
ground or
Joshua, the
anything.
difference between those things that can come out, because the different warnings.
So that's actually what I can explain here myself. So basically, when they issue, I can actually point to examples here. I got examples. I can pull. Sorry, trying to get examples up. So this basically, that's an example of a normal severe thunderstorm warning. So when they say the National Weather Service has issued a severe thunderstorm warning for southwestern St. Charles County, southeastern Warren County, north central Franklin County, until 11 p.m. At 10:08 p.m., a severe thunderstorm was located 2 miles south of Dutso, moving east. Moving east at 35 miles per hour. Expected hazards include 60-mile-per-hour wind gusts and quarter-sized hail.
Norman, pull the car in the garage.
that is basically what I call a normal severe thunderstorm warning, just a general severe thunderstorm warning. But when you get to with that hail or whatever, it gets up to golf ball sized hail or 1.75 inch hail, it goes to a tag called considerable. And then when you get to baseball sized hail or 2.75 inch hail, you can get a tag called destructive.
Oh.
Dang right, that's
And that destructive tag is purple, and the considerable tag is.
Hear that on the weather radio?
Yep.
Mm-hmm.
I can actually play an example if you would
Oh,
like.
Oh wait, Joshua.
Elsa,
Real
Miriam
quick.
knows about that.
Real quick, so I know sometimes they issue tornado watches and sometimes
Yes.
tornado warnings. Which one is more severe? Which one is a more significant risk?
So actually, a lot. So one of the
Between a watch and a warning.
Yeah. I can
the neat thing is I found this is not
Explain the watch and the warning.
this is not a I just find this interesting. One of the National Weather Services, I think it was in central Nebraska, not Nebraska, North Carolina, they actually explain the difference between a watch and a warning. They have a more fancy, but the more common term you have is a taco watch and a taco warning. Taco watch is basically you have the ingredients there, your meat, cheese, lettuce, and shells. It's all here.
yes.
Mm-hmm.
And a warning is you have the taco and you're gonna eat it, or it's in
been
your mouth.
Assembled. It's in your mouth.
The
Oh
taco
my goodness.
exists.
No,
Yeah,
the
that's a
the
serious
observed
warning.
tornado warning is
Right,
it's
like
in
the
your
tornado
mouth.
could be
Okay,
right
so a
there.
watch is basically the stuff, the ingredients are all there that there could potentially be a tornado.
Right.
And then
Could be
a
a
warning is
taco.
Right.
The
It's
taco
Right.
is happening. The tornado has formed. Or, you know, the tornado is active.
Like, uh-oh, you're
Happening.
gonna be eating a taco.
I can
So
That
the
makes
warning is
sense.
when the sirens are gonna go on.
after this Q&A, I can actually play examples of all those
Now
warnings. If
what
there's
time is it, sweetie? Unfortunately, Elsa has to bug
I
out
will
pretty
have to
soon. What? What is it? Time?
It's
9:17.
Okay. Okay.
Are you also gonna go, Lorraine, or
Just because she
do you have
has.
to go, or
I mean, I don't have anything tomorrow other than
okay,
church.
then I'll just go.
Okay.
all right.
Are,
So
are you wanting to do your present from us? I mean, or not? Or you just
Are
wanna
we-
do it?
does anyone have any more questions?
You've done a great job.
Yeah.
I'm impressed,
Awesome.
Joshua. You're my
Anyone have
kid,
more
but I mean,
questions?
I'm very impressed.
I've learned.
Everyone
What?
asked
So,
everything I could even think to ask.
I have one more. So,
Yes.
what causes the difference between snow and hail? Because they're both made from coal. So, what makes something snow? What has to happen for something to be snow, and how is that different than the thing that happens when it makes something hail?
What are the different conditions?
That's a good
I guess.
question.
So obviously heat rises, so what is called updraft, when I
Okay.
refer to max updraft velocity on my videos, that's like the speed of how fast the hail is moving. So like and it just kind of when you get to a certain point in a cloud, it becomes freezing. So then becomes a freezing point. That's how you get hail. So, and then stronger the updraft, the bigger the hail is.
Okay, that
Wait,
makes
but what
sense.
about-
And
What
so,
about
Wait,
snow?
didn't we learn
So-
about this in school
there's-
too, where
I think I
it
remember this from
depends
magic school.
where the freezing happens on whether it's hail or snow? Like where in the atmosphere? Or am I wrong?
Okay,
I don't.
Like I think what Lorraine is asking is
What's,
they're
why
both
does
freezing.
hail?
Why
They're
is
both
one
freezing,
snow
but
and
why
one
doesn't
hail?
it all just freeze into
Why is
hail
one
or all
ice?
just freeze into snow?
You
Well,
want
we
me to
read
help?
in the
I'm more
homeschool
Yes,
than
we
curriculum
do.
because it's where
Okay,
it's in
sure,
the atmosphere.
Sure.
Because
So,
then there's sneak too.
Snow is simply the fact of precip that's essentially condensing and is too heavy to be held up in the atmosphere.
Okay.
So kind of like in the summertime when you get just rain showers, or when you transition from fog, super dense fog, and then now it starts raining, and the droplets at the molecular level come together, and then the atmosphere they just can't hold anymore, so they literally fall. If that happens when it's in the wintertime and it's freezing at the level, that's when you get winter precip. And winter precip can take several forms, as we all know. That can be freezing rain. So in other words, it falls if the ground temperature is basically below freezing, it rains and then it freezes on contact.
Okay.
Okay, so freezing rain is
Versus-
regular rain, but it freezes when it comes
Right.
down. Okay.
And if we remember that heat rises, okay, when we in the wintertime, when we have a front that comes through, we basically have cold rises or heat rises, but we basically have warm air and cold air boundary, and they can literally have like a wedge, okay, and so when you get to like sleet and things like this, it ends up falling through warmer air. So it's cold air loft, hits a warm pocket, unfreezes, and then refreezes before it hits the ground, and that's where you're
So
getting
that's
your
why
sleet.
it's not a neat little snowflake, because it's melted already.
Exactly. It went through warmer air in the atmosphere before it hit the
kind of
ground.
slushy.
Yeah.
The difference with the hail is what you're getting to.
You were-
So we talked about the storms being
Well, are you
40.
trying? Hold on. Are you wanting to explain the different sizes of hail? Is that what you were kind of talking about?
That's just in general with the different sizes. That's what I was saying.
What happens? What does the updraft do with the hail?
So the updraft carries basically, kind of lifts it up and
Keeps
it
lifting it
kind
up
of keeps
till it gets.
yes till
bigger
it
and
gets too
bigger.
heavy. Yes.
He's freezing more every time.
Yes.
He gets shoved back.
So
up.
it's kind of like coating it each time.
Yep.
It's like when you make a snowman.
Yes.
It just keeps adding on and
Yep.
adding on.
Very
and
much
adding on.
like.
Yes.
Okay.
You take dust particles that are in the atmosphere, the moisture will condense on those. You have the violent updraft, but you also have a violent downdraft. You have so you have inflow coming from your warm, moist air, and you have cold air coming basically from the back end. That's how you're getting this moving around. Warm air going up and spinning around, cold air coming back down the opposite way. So when you have rain, either rain, that's condensed. And remember, we get up to about 14,000 feet. That's usually a lot of, and we could show you a chart at where the freezing is at, okay, where freezing point is. So when the rain basically falls, you have this more moist updraft that literally pushes that rain up. If it pushes it up above that freezing boundary, it's going to do what?
Freeze.
It hits the cold downdraft, it's going to come back down. But a lot of times that can get picked up because we have a mesocyclone going on. And the more violent the updraft, the more times that can be carried up through that cycle. That's why if you take a hailstone and you cut it open, it's going to look like you do with the making a snowman. It's going to have layers and rings for the number of times that it's been kind of cycled through.
That's interesting.
That is interesting.
Like a hot air popcorn popper that just keeps on pushing it up.
Exactly.
And the neat thing, so what?
She heard something out here. What is it?
Sorry.
It's over. Come here.
What's going on, Dixie?
Those people have been out there, Dixie. You just missed them.
You just been
No, I think he hears Uncle Tony doing something. Who was that? I didn't catch who was doing something.
Well, that's interesting, Joshua.
So
Thanks.
basically, also what sometimes also happens is if hail gets so big, you could actually have part of the storm that actually kind of juts out like a line here. That's called a hail spike
Oh.
because the hail is so big.
Oh.
That's interesting.
You sure do know a lot.
Yeah,
Oh, yeah.
it's very interesting,
Thank
actually.
you.
I mean, before I had you and Uncle Carl be interested in it, I, quite frankly, never really thought much beyond how it affected my day.
Yeah.
But now I realize it's just really
Oh,
pretty
there's a lot of
interesting,
stuff
Yeah.
going on.
the backstory to it
Yep.
all. Thanks a lot, sweetie. That was really cool. We'll have to have more of those.
And you do a good job of presenting it.
Thank you. Thank you. And I'll actually next year probably I might do one. So
Yes.
Oh.
Let's
so
do it.
and there's actually and I'm gonna probably plan a trivia for my
That'd be fun.
for my weather overlay.
Let's do it.
Oh, nice.
Yeah.
So I can
We'll
play.
have to study.
Grandma's telling you something.
No, this is aside. This is not the subject that this isn't a way how the weather's affected. What that cloud up there? Did we take that picture?
The puzzle?
Yeah. No,
You mean the puzzle?
the frame.
Yeah, that's the puzzle that you got. Ow. 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 Here. Ow. It's
That's
okay.
for not giving her any pizza.
Yeah, that's the puzzle that you got him a while back, and he built it several times, and then you had it glued. You glued it for him, and then I just stuck it in that frame. I need to get a map for it, but yeah,
No, that's fine, but it looked so familiar.
yeah.
that's
You
good.
had bought that from when he was younger, and he did it several times. And so, like I said, you had it glued. I think this would be an honorary time since tomorrow is June 1st to change your calendar, your weather calendar,
Yay.
be
Let's
next
see,
month.
let's see, let's see.
and see
Let's
what's
see, everyone.
on there.
Here, actually, unfortunately, I will take a video for you all on the video there. Just an honorary.
Are you wanting me to video it?
No, I can, but I don't want people in it. People's faces in it.
Okay.
So.
Oh, yeah.
'Cause
All right,
Yeah, Jim wrote.
here we go. Let's get going, people.
Whoa!
That's pretty
That's
neat. That's a pretty blue.
Now, what is that? Is that a dust storm? What is that?
It looks a little.
Where is that?
What's
Where,
that?
where and what is that?
It's like a
Does
cloud
it say?
ball of something coming over the mountains.
What is the
It
is there
says-
information on there, Joshua?
Is it? I can't tell if there's a description.
Can't do it.
All I see is
Girls, can you do that with your phone?
No,
Uh-uh.
I can't even roll my R's.
I can't do, like, I can't fold my tongue.
Yeah, Grandma can do
Whoa,
it.
holy
I
cow,
can't do
Grandma.
anything.
I can't
Whoa!
Tony, can you do that?
I'm sorry.
What?
Can you do that?
So
roll your R's.
That.
I think you should be come over. Where's the sun at? Where would we be kind
Behind
of?
is on top of those clouds.
Yeah, so sun's kind of back over here. We've got some mountains, and this would be a wedge cloud, what we refer to as a wedge cloud coming in.
Interesting to see if
So
we
we've
ask
got
them. Must be
warm,
right
moist
there.
air. This cold
It's
air
genetically
is falling underneath, undercutting it.
It is genetic.
And so you would have more of a thunderstorm that's pushing all these clouds, a mesocyclone that's pushing these clouds. The jet stream is basically blowing on top of that off. So,
Wait, Josh.
yeah, because the sun's kind of going through it and stuff like that. This will be a lot of wind out ahead of this. This will be probably 60, 70 mile an
Are
hour
those
winds ahead of
sunflowers
that.
on the bottom?
What's that?
Are
Mountains.
Those are just.
No, those
Okay.
are mountains. And it's
Well,
kind
no,
of,
I know. I just meant the yellowy part
Yeah.
on the bottom.
yeah, it looks like kind of like a desert type.
So Joshua, have you learned about the Dust Bowl at all in school?
Oh, wow.
In like your history classes and stuff?
I don't know that we have
I
yet.
don't think we have.
Well, when you get to it, it's pretty interesting. We had to read a book about it in my recent American history class, and it's interesting how much like the weather was affected by it and everything, and like
Oh, I believe that.
yeah, like the
Yeah.
weather was
How does that also?
It was in the 1930s.
Okay, so we're still because
it was
we switched to geography from
Mm-hmm.
American Republic, which is where we were, but we stopped pretty much right around the Civil War.
Mm-hmm.
So we'll now in this next history be going through more stuff.
Yeah,
We'll probably
we-
study it. I would
Yeah.
imagine it would be in just the history, right?
Yeah. Oh yeah, most history classes go over it. Yeah, but none of it before we read that book. I had no idea just how like
They haven't
obviously we were like, oh yeah, it was a pretty bad thing, but I did not realize just how like utterly devastating it was. Like it destroyed like all of that central
Yeah.
southern.
Things
Area.
like that
Like-
just affect population.
Yeah.
The temperatures, the sun, and then
Oh, yeah.
things
It was
die.
like
I
yeah, like
was in the way.
Yeah.
the like livestock were like massacred.
Yeah.
Like everything died. And like people would get dust pneumonia where literally like
Believe it.
if they died they would like autopsy them
Do
and
you
their lungs
remember
were
that,
literally
Mom?
just
No, I don't.
Well, not that you
completely
lived through
filled
it. I
with
just
dust.
mean.
Filled with dust.
Well, I'm reading. What were you saying?
And yeah, honestly, the book I still have the book we read because I bought it. It's called The Worst Hard Time. And it'd definitely be above Joshua's reading level, but if you wanted to read over it and kind of to get some background to teach it.
Just kidding.
It
No,
was
I
very,
do.
It was a very
That's
informative
something he
book.
would find interesting because it's weather related.
Yeah.
It has to do with.
Yeah, and the book did a really good job of like
The dust was so strong, so much, you could taste it in your mouth.
oh yeah, no, yeah, it was literally like
How'd you know?
people had to like stuff
How'd you
rags
know?
under
I
their
was told
doors.
about it.
You were told about it,
And
and
it
that's what I
would
mean.
still-
I was just wondering.
Yeah, and it would still like get literally everywhere.
Well, kind of like our pollen when it gets so bad, and that's
I
not
wouldn't
even.
mind reading that book, Elsa.
Oh, it's a really interesting book. And
Same thing.
Well, I'm reading about this. It's a novel, but it's set in Bakersfield, California, and they talked. It was back in the '60s, late '60s, '70s, and they would have these dust storms. They had a few dust storms, and for some reason there was a bacteria in the soil, and the storm would
Huh? What?
basically get this bacteria in the air, and people would get this thing called the fever. I forgot what it's called, something fever, and like literally you could die from it, and it was only this bacteria in the soil in like certain areas, and like if it got in your lungs and stuff, it would be
Deadly.
yeah.
yeah.
And it was stirred up by these dust, getting too
Yeah.
dry, and these dust storms, and this bacteria could cause rashes and all
Yeah, but
kinds of
with the-
skin
Oh my gosh. With
Ignore
the
a wrapping
Dust Bowl-
job there.
With the
Isn't that a
Dust Bowl
pretty
dust
wrapping
storm,
job?
it would be like actual like tons of dirt that were in the storms at one time.
Happy
Yeah,
birthday.
this is
Thank
the
you.
worst. We're
You
just
know what
so-
it is?
Gaming chair.
It's a new
Oh,
chair.
cool.
Wow.
A what?
So
Does
this.
this one have holes so we can see through it?
That's cool,
Yeah,
Joshua.
we can put it together another
Yeah.
time. I think
Nice.
Mom
So
just
what is a
wanted you
gaming
to say
chair?
happy birthday.
That's what he's
Thank
sitting
you.
in right now. But
Is this a better one, Joshua?
this one has speakers on the back.
Whoa.
Oh, that's
fancy.
Does it vibrate and stuff when something happens?
I don't know. We'll see.
No, I don't know if it does that. It's just got speakers on
But
the
this
side
one-
that can be Bluetooth.
This one will go where you're sitting.
Ooh.
Oh, more seating.
He didn't.
Yeah.
That one's getting rubbed. That one, I don't remember what the problem is with it, but he wanted one, and that's one thing he asked for his birthday
Yeah.
season. So we'll put that one over there.
Oh wow.
Cool. That's really
You've
neat,
got a
sweetheart.
couple
Alright.
cards in the kitchen too, Joshua, from both grandmas.
Well, we've got a card for you too, sweetie. But you know, you don't.
I
have to
figured
have any-
let's-
you
Open it,
don't-
whatever.
Everyone,
Yeah.
are we finished with the Q&A?
Yes. Yes.
All right,
You did
say
a good
bye,
job,
everyone.
Joshua.
Say bye to the
Bye.
video. Bye.
Good job.
See you all later. Thank you. We'll see you all later in the next weather video or live stream.